Good day, hello everyone. I hope you're doing well. I'd like first of all thank you, the ICSET 2022 organizer of this conference, for accepting our paper and inviting me here today. That's an honor to have the opportunity to address such a distinguished audience. Let me introduce the authors. First, myself. I'm Rezaei Abadchi from American University of Technology in Tehran, Iran. I graduated Master in System Engineering and I've been working in ICT aspects since 2010. The second author is Kaveh Mohammad Cyrus, PhD Professor of Industrial Engineering and Management System from American University of Technology. My presentation will take about 10 minutes to cover, so welcome to my presentation. Let's start with this question: how to prioritize our final strategies and goals. Have you ever been in a situation as a decider or a manager to sort and prioritize between complex criteria like goals, strategies, and assign or allocate resources, time, money, or organizational energy on them based on their importance and their weights? That's all the same for big enterprises and big companies. Our paper ID is 591 with the name Designing a Model for Prioritization of Strategies Using Combined Fuzzy AHP and FAHP-FTOPSIS. We would like to concentrate on decision-making process in prioritization and sorting our alternatives, and you will be familiar with using the procedure of our proposed model in this regard. This study used an integrated approach combining two prioritization techniques, namely fuzzy analytical hierarchy process FAHP and fuzzy technique for ordering and preferences by similarity to ideal solutions, we call FAHP-FTOPSIS. Through weighting and rating the set of alternatives, fuzzy logic concepts and fuzzy interface systems can reduce human judgment errors and subjectivity in decision-making process. The data were submitted to the MATLAB fuzzy logic toolbox to demonstrate the validity and reliability of the proposed model. The achieved ranking were compared with those of the traditional and conventional practices and methods. Most organizations have now organized the strategic planning necessary to adapt with the rapidly changing work environment and to maintain sustainable growth while gaining competitive advantages over their competitors. Senior managers and experts teams always need to make decisions on how to allocate resources. Okay, now we should decide between which is best one, an optimal one, the old way, or a new way. We proposed a new model. In classic methods, decisions often were made based on a subjective selection of certain alternatives, whereas with the emergence of advanced management tools, which employ diverse quantitative techniques and new algorithms like multi-criteria, multi-attribute decision-making, we call MCDM, MATLAB techniques. However, there exists many uncertainties on internal and external factors to make the exact criteria and factors to make exact criteria for selection of the strategies practically out of reach. We developed a combined fuzzy AHP and FAHP-FTOPSIS model through which the best way for the internal and external factors and proximity index to ideal solution and non-ideal fuzzy solution for a strategy ranking were achieved. As you can see in this figure, we have a roadmap and overview of our work after acquisition with the steering committee, with our case study company, National Drilling Company, which is the biggest one in the oil and gas industry. We collect some criteria and strategies as a main basic framework. Then we extracting the internal and external factors like weaknesses, strengths, opportunity and threats, and some kind of sub-factors. And then we start the defining hierarchy chart based on the problem and creating the trapezoidal fuzzy numbers for pairwise comparison. And then we check the consistency check and obtaining the weights of each factors. The output of this part is as the input of performing FAHP-FTOPSIS, evaluating the strategy by FAHP-FTOPSIS. And then we select the ranking methods based on between distances of negative and positive fuzzy ideal solutions. Okay, let's move on this because it's the procedure of the FAHP-FTOPSIS and fuzzy methods. Our proposed model is based on these flow charts as described in earlier position. The hierarchical structure of the prioritization of strategy in our cases is the figure like this. A hierarchical evaluation criteria system was established and 4 factors and 18 sub-factors were included in the criteria systems, as you can see in this table. 6 strategies formed and developed alternatives, as you can see here. The trapezoidal fuzzy numbers were adopted to determine the weights of the all factors and stability matrix. The fuzzy vectors were then calculated and entered into the FTOPSIS models for related calculations and ordering of the strategies as started earlier. To prioritize the strategies, a fuzzy hybrid methodology we applied. You can see here. We can in a fuzzy methods try to convert linguistic variable to the trapezoidal fuzzy numbers, which is more accurate and have more reliability. And then we can weigh the fuzzy numbers to each of decision makers for each of the sub-factors. We calculate our mathematical models in a MATLAB logic, fuzzy logic toolbox and simulate the results. Let's move on this because it's all in our original papers and you can see if you want for more details. And the priorities yielded by the combined fuzzy numbers. Okay. In the results section, and if we want to interpreting the new ranking of the strategies shows the priority level of the strategies. For example, as you can see here, the level of the strategies number 2 and 3 has not changed. The both in new model, proposed model, and the conventional model is the same with no change. And this strategy number 4 and number 5 demonstrated only 1 level shifts. However, strategy number 1 and strategy number 6 show drastic shifts on priority and implying that the ICT management need to invest more on development its infrastructures than the security issues, having achieved more reasonable, reliable results. The NIDC steering committee and top executive managers agreed on the effectiveness of the proposed model in comparison to their traditional models and decision making. You can see in this figure the comparison between the proposed and traditional models, which shifting some of the our strategy priority. We can also the simulation using the MATLAB fuzzy logic toolbox after inserting primary decision makers data and defining two membership functions, fuzzy AHP and fuzzy TOPSIS. The algorithm implemented with the fuzzy set comparison matrix into, and the output priority ranking was simulated with modification in input variable which is available. And in the conclusion section, I'd like to say that the results demonstrated the high capabilities of the model as a systematic and significant decision making support tool in prioritization of the strategy, and using fuzzy and mathematical methodologies through a qualitative approach has the advantages of the preventing deviation and biasness during the strategy planning and prioritization process. It should be noted that although calculation and application of the proposed model might appear rather complex and lengthy, it is still worth using due to the provision of more accurate and reliable sorting of the priority for decision makers. And based on the result of this paper, the following suggestions are made for further research. For instance, in number 2, the strategy 6 was obtained in a commixture of the 5 factors. In real strategy planning, each strategy comes from mapping more than 2 elements, and that is using a fuzzy model for strategy making during a SWOT analysis, which is the most effective tools in strategy planning. We call SWOT metrics, or strengths, weaknesses, opportunity, and threats, which collected by the steering committee in every organization. And number 4, as you can see in this slide, in most of cases with dependency between factors and sub-factors, applying ANP methods is available also. And finally, because of the time, I can try to briefly present my paper. You can see the detailed formulation and the figures and tables and details of our methods, especially fuzzy analytical hierarchy process, FAHP and FTOPSIS in my original paper. And if you can or need any further information, you can contact us for example, M-file for MATLAB. And at the end, thank you for your time and attention. I hope you will have the gain and insight into this paper. Thank you.